All right. Today's the 29th of March, 2026. We're doing POTD. Check if strings can be made equal with operations. Number 1. All right. You're given two strings, S1, S2, both length 4, consisting of lowercase, both length 4. Oh, wow. That's very specific. Consisting of lowercase English letters. You can apply the following operation on any one. Wait, what? You can apply the following operation on any of the two strings any number of times. The following operation on any of the two strings any number of times. Okay. Choose any index, I and j, or any two indices. Pick any two indices, I and j, such that their difference is 2. J minus I is actually 2, so j should be bigger. Okay. J minus I is 2. Then swap the two characters at those indices in the string. Return true if you can make strings S1 and S2 equal and false otherwise. So you are basically just... Wait, so you're basically just trying to take the first string and rearrange the letters to make... So it's an anagram, basically. Is that the question? Is it an anagram? They're doing all this weird swapping business. Is the question just, is it an anagram? D-A... Okay, it's not, because... Oh, okay. So even if it is an anagram, there are cases where that won't be the case. Why is that? So in this case, A, B, C, D becomes C, D, A, B. You could, I guess, swap the C and A around maybe. And yeah, swap the C and A, swap the D and B. So two operations, so you return true. This one, I'm curious, why can't you... All right, let me write this one out. So A, B, C, D, D, A, C, B. So A, B, C, D, and D, A, C, B. So what would happen, let's say... So the C is already in the right place. And I guess the A and the B, if I swap those around, whoops. If I swap those around. Wait, what? Wait, did I say this wrong? Wait, did I make... Maybe I misunderstood the question. A, B, C, D, D, A, C, B, right? And the operation... Oh, the difference has to be 2. Right. Okay, that makes sense. I forgot about that condition. Okay, so I just have to write J minus I. That's why. Okay, so that's why it's not just a... I think if not for this condition, I think it would literally just be a question of if they're anagrams or not. But because of this condition, it changes. I need to make this thicker. So J minus I needs to be equal to 2. So the difference between the two indices you pick has to be equal to 2. So what I think you can do is... In my mind, it's like just greedily pick... Like, notice that this A, for example, is in the wrong spot, right? The A is in the wrong spot. So figure out where it should go here. And if that position is, within 2, then conduct a swap. That way we're kind of one step closer to getting to the right solution, right? And then the B is in the wrong spot, but it needs to be sent over here. So then that's too far, so it's false. But then how do I know that? Is there any case where... Like, what if I chose to move the B first, right? Like, what if I was like, oh, the B's in the wrong spot for whatever reason, right? So I move it to the right place. Wait, I'm confused now. Wait, are you sure this is false? You can apply the following operation on any of the two strings any number of times. On any of the two strings is interesting, but I don't think it would really make a difference. I think you can just do it on one string over and over again. Choose any two indices, I and j, such that j minus I is equal to 2. Then, equal to 2. Exactly equal to 2. I'm so silly. Sorry, I keep thinking that like it's at most 2, but it's exactly equal to 2. Okay, okay. So then yeah, you basically are looking for where is this position. So this was originally here, right? A, B, C, D. So, okay, is the position it needs to be, is it 2 away? Yes, so swap. And then from there, is the position this one wants to go, is it 2 away? No. So it's a problem. The fact is, like, if I ever want, like, this A, for this A to get over here, right, it needs to be exactly 2 away. If it's 1 away, like in this case, then I'll never be able to make it such that the A is in the right position, right? Because, like, even if I'm, like, trying to move this one around as well, they're always going to be not 2 away. Because I'm always going to be moving this one 2 away. Or if I move it, like... I think if the difference between a letter and its if the difference between a letter's original position and its target position is even for all the letters, I think you return true. And then if it's odd for any of them, you return false. Because I don't think it's possible. I think if, so like for example, if I have A, oops. If I have A and then like, so 1, 2, 3, 4. Ah, and it's only 4 letters as well. So it's not even about being even. It literally has to be 2 away. 1, 2, 3, 4. If the A isn't here, I think you're in trouble because how are you, if the A is over here, here, or here, well, not here actually, sorry. If the A is here or here, how are you ever going to make the A like get in the right position, you know? I'm assuming there can be duplicate letters. Yeah, okay. If the other A is over here, so let's say this is X, 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 and this is X, X, X. But like if this A is here, this A is here, there's no way you're ever going to be able to do a swap that lets you sort of make them converge in the same position. Because their difference is 1. So no matter how you shift it, the difference between them will always be odd because you're always moving by 2. So you never have a position of like a difference of 0 in their positions. So I think that's it. I think find for each letter, so for each letter in the original string S1, if the same letter exists in S2 at either the same position or at like the 2 away position, then no worries. Move on. Whoops. Move on to the next letter. Else, return false. And if you go through that entire for loop and nothing bad happens, then return true. Is my thinking. So now the cleanest, I mean, it's only 4 letters, so I feel like efficiency isn't really the issue here, but we could do like a we could do like an easy hash table, I guess, if we wanted to. It's 4 letters, whatever. Does the find thing in strings, does that return the smallest index every time? That might be a problem, because if there's multiple, then there might be... Okay. Okay, we'll do it. No, it's easy, because it's exactly 2, so I don't have to actually use any data structures. So for C in S1, I guess I have to enumerate as well to get the index. For IC in S1, if S2 at I equals C, then no worries, continue. Elif I is less than 2, so it's either 1 or 0, and S2 at I plus 2 is equal to C, then no worries, continue. If I is greater than or equal to 2, so it's 2 or 3, and S2 at I minus 2 is equal to C, then no worries, continue. Else, I think we have the problem and we return false. And then we return true. This is my understanding of the question. Like, so this is basically just saying, like, if you're looking at a letter that's in the first half, then if you, like for the B, for example, you would have to look 2 ahead. But if you're in the latter half of the word, then you'd have to look, 2 behind. Well, in this case, you would look straight here. But here, you'd have to look 2 behind, right? So you do I minus 2 or I plus 2, depending on where in the word you are. And yeah, that would be my basic understanding of the question. I don't know if I've missed anything. Like maybe like I've made this claim, right? Like, oh, in order for it to be swappable, it's true if and only if for every letter, either at the same position it's the same letter, or 2 across it's the same letter. Like that could be something that's interesting to prove, but I feel like intuitively it makes sense. Definitely, I know for sure that if that's not true, like if A is here and A is not here or here, like if it's in one of the other positions, then I know for sure you will never get, this should definitely return false, this case. So I'm very comfortable returning false here, because like there's no way you can shift the A around to make them match, because of the reasoning before, like the difference will always be odd. The difference in positions will always be odd. I know that. Is there ever a case where, A is here, A is here, and like B is here, B is here, C is here, C is here, and D is here, D is here? Is there ever a position where like this wouldn't return true? Like, I don't think so, right? But formally writing out a proof would be a bit weird, I think. Like, how would you word that? Something about like, if for every position, the difference between itself and its target is even, then the moves can be done such that I wonder if you extend it to 6, like E, F. This is why they made it 4, because both these guys would be looking at the same, would want their target to be in the same place, unless of course these were matching already. But okay, interesting. Anyway, so I can kind of see why they made it 4 specifically. I guess it'd have to be like a multiple of 4 to make it make sense. Anyway, I'm pretty confident in. Did I check this already? I'm fairly confident, although this acceptance rate is getting me scared now. Is this am I missing something? I think I back it. Okay, very good. Nice and simple. After yesterday, I'm glad, because that could have been very bad for me. But yeah, honestly, I sometimes I rush ahead, don't I? Like, I literally forgot this twice. I forgot this condition twice, and then like, I was like, what's going on? All right, and then what's the cleanest way to write this? I could use like a mod, but I feel like that's a bit overkill. If RS2 at I is equal to C, should it be one big or S2 at I plus 2 mod 4 is equal to C, and then wrap that entire thing in a knot. So this is like the valid case. So if I negate it, then return false. I personally prefer the first way because I just think it's easier to understand what's happening, but this is shorter, so looks pretty, I guess. Either way, whatever works. And then of course you could get rid of the magic numbers and stuff. But yeah, very good.